This is 1-7, transformations in the coordinate plane. First warm-up problem says to draw a line that divides a right angle in half. So let me draw my right angle. Notice I placed the 90-degree box right inside there to show that that's a right angle. And I'm going to cut that in half with a bisector. I can give these letters like A, B, T, E. So my bisector is ray AB. Okay, draw 3 different squares with 3, 2 as one vertex. Well, let's graph that first. 3, 2, x, comma, y, right? So I went to 3 on the x, 2 on the y. Graph that, and then I can draw 3 different squares that hit that point. So 1, 2, they all have a common vertex. That point 3, comma 2. Okay, and for the last one, let's take the x plus 1 and set it equal to 3 for the x value, and the y minus 3 and set it equal to negative 2 from the y value, and solve each one of these. X equals 2, and y equals 1. Okay, so a couple things you need to know here. The first thing you need to know is that we start with a pre-image, which is the original image on a graph. And then we're going to transform the graph in some way. So we'll have a new version of the old image. So the pre-image and then the image. The pre-image is labeled as, for instance, triangle ABC, and the new image, the transformed image, is A prime, B prime, C prime. So we know which one was the original and which is the new image that had a transformation to it. And there's 2 different kinds of transformations. You may have heard of these before. A reflection is like a flip over the axis. It could be over the x-axis or over the y-axis. A rotation is where the figure is spinning or turning. And a translation is where an image slides. It could be going up, it could go down, it could go up and to the right. It could go down and to the left, down and to the right. It's just sliding in some way. So when I look at example 1A, I know that my pre-image is in blue because these are the original letters, A, B, C. My new image after it was transformed is A prime, B prime, and C prime. Okay, to see how this transformed, it did not flip over an axis, and it didn't slide because I can tell that it actually spun. If I made a copy of the A, B, and C, and if you watch, it actually turned, it rotated like this. That means that we have a rotation 90 degrees, and that's counterclockwise. So we label rotations with the amount of degrees that happened in the transformation, and then we state if it was clockwise or counterclockwise. So triangle ABC maps to A prime, B prime, C prime. Let me put a triangle in front of those. Triangle ABC maps to triangle A prime, B prime, C prime. In example B, notice that the D was in the top left of the pre-image. Remember, the pre-image is in blue because those are the regular letters. So the D is in the top left, and for the next image, the D moved to the bottom left. So this can't be a translation because it did not just slide. It actually flipped over. Since the spot was switched, it flipped over. It didn't rotate around, but it did flip over the x-axis. So this is a reflection over the x-axis. And so rectangle D, E, F, G. We go in order. Once you pick a point, go in order. D, E, F, G. Maps to rectangle D prime, E prime, F prime, G prime. Okay, in example 2, we're going to need to graph all of these points. So to do that as the first thing, and make sure you label them as A, B, C, and A prime, B prime, C prime. Here's my pre-image in blue. You might notice right away this is a mirror image. So this is going to be a reflection, and it's over the y-axis. It flipped over the y-axis. So this is a reflection over the y-axis. I knew it wasn't a rotation because the image did not spin. The letters didn't turn from their position. And I knew it wasn't a translation because if I translated it, the A would have remained on the left side of the image. And in red, the A ended up on the right side. In a translation, what's happening is you're really just sliding the image. So you're either moving the image along the x-axis, which would be to the right or to the left by adding or subtracting along the x-axis, or you could add or subtract on the y-axis. Adding would bring your image up and subtracting would bring your image down. And so that's what we're saying here. Translations can be described by the rules such that for x, y, x had something added to it and y had something added to it. This could also be like x minus a or y minus b, but we just say adding a negative in that case. So it's x plus a, y plus b. So find the coordinates for the image of triangle ABC after the translation, x plus 2, y minus 1. So I drew my image and from the previous problem, same coordinates, and now I need to translate this image. So I wrote down the original points for A, B, C. Now I'm going to come up with my points for A prime, B prime, C prime. Now remember that the x is adding 2, so I'm going to add 2 on my x value, so the 1 add plus 2 gets me 3, and the y is subtracting 1. So negative 1 minus 1 is negative 2. Same thing for this x value. I'm going to do x plus 2, so 2 plus 2 is 4, and for this I'm going to do y minus 1, so 3 minus 1, which is 2. And for the last one, same thing again. So I'm going to add 2 to the x, which is 6, and I'm going to subtract 1 from the y. Negative 2 minus 1 is negative 3. And I'm going to draw this as my new image. Notice that the A is in the same position, the B and the C. It's just that everything moved over 2 because it was x plus 2, so the right 2 on x, and then it moved down 1 because it was y minus 1. So from hexagon 1 to hexagon 2, for this problem, if you look at one of the coordinates and its matching coordinate, what really happened was that we went to the left 1, 2, 3 spaces, and then up 1.5 spaces. So left 3 would be on the x, we went left or negative 3, and for the y we went up 1.5. This is our rule for the translation.